Hello, this is a lesson on radian measure as another way to measure angles other than degrees, which we're used to. You would have seen radians when you go to change your calculator mode from radian mode to degree mode. Radians is the other. I kind of like to think about it in terms of the metric system and our American system, whereas we can measure distance in miles or in kilometers. We can measure weight in pounds or kilograms. And so it's just a different way of measuring angles. So radian measure is in terms of pi. So all of your radian measurements, you're going to see the pi symbol as part of that measurement. So where does that come from? Well, these right triangle and just in general trigonometric functions are all sine, cosine, and tangent. Those are all circular functions. So when we think about that, we look at a graph of circle functions and it looks more like this as opposed to our rectangular coordinates that are on our coordinate plane with our x and y values, our x and y axes. This is kind of thinking in terms of measuring angle measurements as opposed to distance left, right, up, and down with your x and y's. So this kind of sits on top of those rectangular coordinates, and it helps us measure circular functions. All right, so that's where the pi comes from. So our formula that we're going to use to be able to convert from degrees to radians or radians to degrees is right here in blue. The degree measure times pi over 180 is our radian measure. So we'll do number one as our first example. So number one here, we've got 325. Oops, sorry. Let me fix this real quick. Move that back down to 4 there, and I think we'll fix this. Sorry about that. Okay, let's try again. 325 is that measure that I'm converting. So that's degrees. So that's going to be times the pi over 180 equals whatever my radian measure is going to end up being. Okay, so I'll go ahead and simplify ahead of time. I'm going to put this over 1 so that I have fractions, so I can do multiply top times the top, bottom times the bottom. But before I do that, I'm going to simplify as best I can. Both 325 and 180 have a greatest common factor of 5. So I'm going to divide both of these by 5, and I get 65 and 36. I check for any other common factors in here, and I don't have any, so I'm just going to go ahead and multiply top times the top, which is 65 pi over bottom times the bottom. 1 times 36 is 36, and that would be 65 pi radians. That's number one, converted from degrees to radians. Number 3 is already in radians, and we're going to go backwards to degrees. So let me clear off the screen here. Sorry about that. Clear off the screen. Oh. And we're just going to work around it. So we'll go with number 3 here, where I have, I don't know what my degree measure is, times pi over 180, that same formula that we just used, and that's equal to my negative 4 pi over 3 radians. So I'm going to have to go backwards here to get degrees. So one of the things that's important to understand here is that in order to get degrees in this equation by itself, I'm going to have to divide by pi over 180 on both sides. So if I divide both sides by pi over 180, that helps me isolate my degrees. But keep in mind, dividing by pi over 180 is the same thing as multiplying by the reciprocal. So the degree measure is the same thing as doing my radians times the reciprocal 180 over pi. And that's how I can convert from radians to degrees. So I'm going to go ahead and do that, checking for any sort of simplifying possible. 3 and 180 both have a greatest common factor of 3. So that simplifies to 60 over 1. And the pi's can cancel out here and here. So now I could go ahead and multiply. Negative 4 times 60 is negative 240 over 1 times, and there's the only thing on the bottom, so that's a 1. So negative 240 over 1 is negative 240 degrees. All right. Now, something I hope that you noticed in number 1 and number 3 were angles that are not normal for us. Up until now, we had angles that were anywhere between 0 and 180 degrees. We thought about lines, and lines maximum angle measure opening all the way up for these angles was 180 degrees. Well, when it comes to circular functions, we get the entire circle 0 to 360 degrees, so it opens up to way more angle possibilities. But because it's a circle and it has that revolution and that repetition, we actually no longer have a smallest and largest angle measure. So angles can be as big or as small as you want, really, really, really positive, or really, really, really negative. So there is no more limitations on what an angle measure can be. We're no longer between 0 and 180.